Welcome back to the second video in the 2D vector series, and my name is Josh, and this time I'll be showing you how to add the vectors. So, a simple practice problem to begin. So, Eric leaves the base camp and hikes 11 kilometers north and then 11 kilometers east. Determine Eric's resulting displacement, also known as the resultant R. So, the steps of this problem are as follows. First, you want to draw the vectors for his trip. Now, as the problem states, he hikes 11 kilometers north and then 11 kilometers east. So if the magnitudes of the two vectors are the same, then the length of the two vectors should be just about the same. And since the directions are different, the directions will obviously be different. Now, what we can do is place them head to tail, as seen here, to form a right triangle. If you notice, we have the head of one lined up with the tail of the other, and we get 2/3 of a right triangle. Now, you can almost imagine there being that hypotenuse right there, and there it is, and that is your resultant R. Now, what you're going to want to do is use the Pythagorean theorem to find R. Now, the Pythagorean theorem states that a squared plus b squared equals c squared. So, what that means in simpler terms is that the value of side a squared plus the value of side b squared equals the value of side c squared. So, 11 squared plus 11 squared gives you r squared. Now, 242 equals r squared because 121 plus 121 equals 242. Now, r will be just about 15.6 kilometers, and that's the answer to this problem. Now, note we could have also used trigonometry to derive the direction of r as being 45 degrees north of east, because we always measure things using the cardinal direction. So, north, south, east, and west. So if we start with east, we can then head north 45 degrees rather, and end up where we should be with the resulting vector. Now here's a practice problem for you to try on your own, and this is a good time to pause the video, and I'll be checking back with the solution to see how you guys did. Now here's the solution to the problem involving Miss Sorrent. So Miss Sorrent's kids are driving her crazy indoors, so she decides to take them for a walk. They walk 10 kilometers north of the park, then 5 kilometers west to get ice cream. Find the magnitude, which is the displacement in the direction of their trip. Now, the same as last time, we're going to draw the vectors for their trip. 10 kilometers north and 5 kilometers west, but note the magnitude of 5 is smaller than 10, so the length of the vector is smaller. Then we're going to use the same head-to-tail method to find the hypotenuse yet again, which you can imagine and then draw. It should be right here, which is also the resultant R. Using the Pythagorean theorem one last time, we can find that 10 squared plus 5 squared equals 125. Then take 125 and the square root, and you get just roughly 11.2 kilometers as your resultant. Now, here's where things get a little bit tricky. According to trigonometry and the rules of SOHCAHTOA, we can use angles and sides to find out other angles in right triangles. I'm sure if you had Miss Malowski, you know what I'm talking about with Cam SOHCAHTOA. So now, we know that the rule for tangent is that tangent is equal to the opposite side over the adjacent side. And we know that we have the opposite side and the adjacent side, so we want to use tangent for this angle that is respective to the resultant R. So now we know that this angle right here is equal to the opposite side 5 over 10. So, the tangent of theta, which is just a Greek symbol representing the angle, is equal to 5 over 10, which is 0.5. Now, if you use your calculators and press the second button, and then the tangent, and then hit 0.5, you'll come up with an answer that is 26.6. Now, most people say, okay, that's my degrees. Well, done. Okay, that's my answer. But however, there's a trick. Now, what this says is that 26.6 degrees is the value inside the triangle. But when we look at north of west rather, we are looking for this value outside the triangle because we're starting west and then heading north. So what we have to do is take this whole bit right here, 90, if you can almost imagine this as being one 90-degree angle. We have to take this 90 degrees and subtract the 26.6 inside to get the resulting direction as 63.4 degrees. And that is how you were to solve a 2D vector addition problem. I hope that this was helpful, and if you have any questions, I'm sure you can ask Ms. Sorrent. Thanks for listening.